In episode 58, Run Patch Management Effectively Without Business Disruption, we bring together the operational and security sides of keeping systems current without turning every update into a crisis. The aim is to maintain both agility and safety by building predictable, low-drama patching routines that leadership, engineers, and auditors can all trust. Rather than treating patches as rare fire drills driven only by headlines, you will see them as recurring, well-understood events woven into normal operations. When patching is handled with this level of discipline, it becomes a quiet strength rather than a constant source of anxiety. Effective patch management starts with a comprehensive, accurate asset inventory that goes beyond a simple list of host names. You need to know which systems exist, where they run, what versions of operating systems and key software they carry, and who is accountable for each of them. Ownership must be visible, not buried in old spreadsheets, so that there is always a named team or individual responsible for approving and validating changes. Documented maintenance windows for each asset or service make it clear when disruption is tolerable, which reduces conflict when updates must be applied. When this inventory is trustworthy and current, every later decision about patching can be grounded in reality rather than guesswork. Prioritization is where patching strategy turns from install everything eventually into focused risk reduction. Not all patches carry the same urgency, and you cannot treat a low-risk bug fix on an internal tool the same way as an actively exploited vulnerability on an internet-facing payment service. You weigh exploit intelligence, including whether proof-of-concept code exists or attacks are being seen in the wild, alongside exposure context, such as network location and data sensitivity. Business impact also matters because a vulnerability that could disrupt settlement operations or leak cardholder data deserves faster treatment than one affecting a non-critical lab. By combining these factors, you build a patch backlog where the most dangerous issues are addressed first in a way that everyone can understand and defend. To avoid surprises, you standardize build and test stages that validate both compatibility and rollback procedures before patches touch production. New patches should flow through predictable environments, from development to test and staging, where automated and targeted tests confirm that applications, integrations, and configurations still behave correctly. Alongside these forward checks, you maintain and exercise rollback procedures, ensuring that if a patch causes unintended harm, you can safely step back without corrupting data or leaving systems half-updated. These stages should be documented, repeatable, and automated as much as practical so that teams know what evidence is required before a change advances. When build and test stages are consistent, patch cycles stop feeling like gambles and start feeling like controlled processes. Deployment itself benefits from automation that introduces changes in carefully managed waves rather than all at once. You start with canaries, which might be a small set of servers, a particular region, or a friendly internal customer group, and closely measure technical and business results. If error rates, performance metrics, or user experience show unexpected degradation, you halt and investigate before broader rollout. When the canary wave proves stable, you expand gradually according to a predefined plan, allowing for pauses and checks between each step. This wave-based approach reduces the risk that a bad patch will harm the entire fleet and gives teams time to react thoughtfully instead of frantically. Maintenance windows are not merely calendar entries. They are agreements that help align business expectations with technical realities. You enforce these windows by coordinating with service owners, product teams, and operations staff so that everyone understands when systems may be restarted, performance may dip, or brief unavailability might occur. Clear communications in advance, including which services are affected and what customers might notice, reduce the temptation to apply emergency changes outside agreed windows. At the same time, you ensure that truly urgent patches, such as those addressing active exploitation, have a defined emergency path that is still structured and governed. When maintenance windows are respected and predictable, patching becomes part of the rhythm of the organization rather than a source of surprise. Because patching often requires elevated access, protecting credentials used in orchestration is a critical security control in itself. You separate patch orchestration rights from day-to-day operational accounts so that routine administrator identities cannot silently push broad changes. Automation tools should run under dedicated service identities whose permissions are limited to the specific systems and actions required for patching, and those credentials should be stored in secure vaults and rotated reliably. Access to these orchestration paths must be logged and monitored, providing a clear trail of who initiated which updates and when. This separation reduces the risk that a compromised account or misused tool can deploy malicious or unapproved changes at scale. After each rollout wave, verification ensures that the change you intended actually took effect and that systems remain healthy. This includes confirming versions and patch levels on all targeted assets, ideally through automated queries that compare against the desired state. Integrity checks, such as file or configuration validation, help catch partial updates or tampering that might have occurred along the way. Service health is inspected through both technical signals, like error rates and latency, and functional smoke tests that exercise key user paths. When verification is treated as a standard step, you avoid the dangerous assumption that deployment completed successfully always means patch is truly applied and safe. Not every patch can be applied immediately, and that reality must be documented rather than hidden. For each exception or deferral, you record why the patch cannot be installed now, what compensating controls will mitigate the risk, and an explicit expiry date for the exception. Compensating controls might include tightened network restrictions, enhanced monitoring, or temporary feature limitations while a proper fix is engineered or scheduled. These exception records should be reviewed regularly, especially when severity is high or affected systems process sensitive data. By handling exceptions this way, you turn unavoidable delays into conscious risk decisions rather than silent vulnerabilities. Metrics transform patch management from a collection of tasks into a measurable program. Time to patch metrics show how quickly the organization can address critical, high, and lower severity updates, revealing whether you are keeping pace with your own policies and external expectations. Coverage percentages highlight what fraction of your fleet is current, nearing obsolescence, or missing important updates, helping prioritize remediation work. Failure rates and rollback counts indicate where patching processes or platforms are fragile, suggesting the need for improved testing or more resilient deployment strategies. Regularly reviewing these metrics with both technical and business stakeholders turns patching into a shared performance conversation rather than a purely technical concern. Many organizations focus patching solely on operating systems and core applications, but a mature program deliberately integrates firmware, drivers, and third-party components into unified schedules. Network devices, storage controllers, hypervisors, and endpoint firmware can all carry exploitable vulnerabilities that attackers actively target. Third-party software and platform services also require updates, and these may involve coordination with vendors or service providers who control part of the stack. By listing these elements in the same inventory and bringing them into patch calendars, you avoid blind spots where some layers remain perpetually outdated. Treating the full technology stack as patch relevant reduces surprises in both incidents and assessments. Communication ties everything together by ensuring that progress, risks, and blockers are visible to the right people at the right time. Regular updates to leadership and key stakeholders can highlight upcoming major patch events, known high-risk vulnerabilities still in progress, and any dependencies slowing remediation. When decisions are required, such as accepting short-term downtime, approving emergency changes, or investing in additional automation, these communications provide the context needed for informed choices. Clear status reports also help demonstrate due diligence to auditors, customers, and partners who ask how you manage vulnerabilities over time. In this way, patch management becomes part of the broader risk narrative rather than an isolated operations topic. A brief mental review of this episode's themes shows a coherent patch management cycle rather than a string of ad hoc actions. You begin with a solid inventory and thoughtful prioritization, then rely on standardized build and test stages and automated deployment waves to move safely from intent to change. Maintenance windows, protected credentials, and thorough verification uphold both security and stability, while exception handling and metrics keep risk decisions transparent and measurable. By including every layer of your stack and communicating clearly, you make patching a steady, reliable process that supports business goals instead of threatening them. This coherence is what exam questions and real-world reviews alike are trying to surface. The practical conclusion for episode 58 is to ground these concepts in one manageable fleet segment you can influence today. That might be a group of application servers, a specific database cluster, or a set of point-of-sale endpoints, but the goal is the same. You schedule staged updates for that segment, define canaries, confirm maintenance windows with owners, and plan verification steps and rollback paths in advance. As you execute this cycle and document results, you create a concrete pattern that can be reused and scaled. For an exam candidate, leading even one such focused, low-drama patch effort is a powerful demonstration of practical assurance. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.